Hopefully in the morning I make you interested in deep learning, and it's very interesting to you to learn more about deep learning. So in this afternoon session, we will talk about some features learned by these deep neural networks, and very cool examples that exhibited in recently, and also some updates where deep learning is heading to. So let's have a very simple task, which is classify handwritten digits. And for our humans, we can easily, because we are trained to recognize zeros, nines as a kid, and feel very natural to distinguish them. But for neural networks, they need to learn in such a way that they can map different categories of digits into different feature maps. Ideally, these 10 categories should be separated somehow in the feature space. So this example I showed you before, but I will talk in a little bit more detail, because the idea of deep learning is that it can works as a very cool hierarchical feature extractor, simulating the way we learn. So for face recognition, we have different layers of neural networks, and each layer is responsible for learn some features. In a lower level feature, like in the hidden layer 1, you learn some basic edge detector. Like in computer vision, you have this whole Laplacian or whatever operator that can learn the edges. And then as you move on with the layers, you can learn fine details of a local area, like a nose or eye. And in the end, you can learn the global picture. So this kind of hierarchical information extraction is very powerful. Deep learning, another cool feature of deep learning is that you can utilize the model that you trained on ImageNet with millions of images, and you can use this model where other people trained, and you can delegate to your own task you are interested in, like this one. So this is a Kaggle competition. Kaggle is a competition for data scientists. This one is a Yelp restaurant photo classification. It had 9 different categories. For example, a restaurant is the environment is classy, is good for dinner, something like that, and it has 200,000 images for training and testing. So what we did is we didn't train any neural network. We just used the people trained on ImageNet and get the features learned from the last 2 layers, and we tuned this model on our task like this one. And then the performance is very promising. It get about 80% of F1 score. And basically, training a neural network from scratch is very time-consuming and tricky. So in the community, people trained a very different kind of grid model that can prove and work successfully, so you can free to use them to work on your own problems, which is very great. And also, in terms of natural language processing, for a long time we want to deal with natural languages into numbers. So one way to do that is map those natural languages into vectors. In the vector space, ideally we want the similar words, the Euclidean distance are similar. So there's a cool, so you can calculate the cosine similarity between the vectors. So a nice example is if you use the vector of Paris minus France plus Italy, you'll get a vector very close to Rome. And this is ongoing research in natural language processing of deep learning. So next I will talk about examples that I think is really cool. So we know about AlphaGo, which is a product from DeepMind at London and acquired by Google. So actually, early on, before AlphaGo, they published a paper that used reinforcement learning. Remember the mouse and maze example to play games. This is a very short demo. So basically, it gives the raw images of the frames of the game and lets the computer figure out the strategy to. So this is the training at 10 minutes, and it basically, like novels, it didn't do much. But at 120 iterations, it plays like a normal human, or an expert. So all the input is raw images, pixels, and you give them reward. Remember, we are games, so we know the rewards. So, and it did a reasonable amount of work, And that of 240 iterations is amazing. So what it found out is it can kick the ball into the tunnel and then, just kicking all the things out there, which is very cool. Yeah. So this is the technology that also used in AlphaGo, deep reinforcement learning. It used the convolutional neural network that we talked about in the morning, where you do convolution and pooling on the images. So anything can be dealt in terms of image is workable. So let's talk about a Go and AlphaGo. I thought this might be interesting to you. So 20 years ago, Deep Blue beat the human champion of chess, and where it used brute force because the search space of chess is much lower than Go. In Go, you have normally you have 19 by 19 board, which is 361 positions. Each position it can be white, black, and empty. So you have 3 to the 361 different legal positions. And not to mention, there's cases where if your stone is surrounded by others, you got move out, and there's other. So which makes this search space more complicated. So brute force just don't work, even with the supercomputers here. So what people came up 10 years ago is monocolored tree search, which is a heuristic searching method. You can think in this way. So I give you 100 apples. I want you to figure out what's the biggest one. I close my eye, I grab one, and then I close my grab another one. So I compare the two apples and always keep the biggest one. So I do this 100 times. At the end, I will guarantee to find the biggest one. But what if I cannot make to 100 steps? I cannot guarantee to get the biggest one, but I always improve. At least I suboptimally. I already keep the biggest one. So that's the heuristics or the idea of monocolored tree search. Basically, want to search smartly in the whole biggest search space. But it is still slow. Since the search is so big. So that's where deep learning comes in. So in the offline training or AlphaGo, you give the AlphaGo the images of these moments of human players. So they are the probably the professional players which are real smart moves. So AlphaGo will use the convolutional neural networks to predict what's the best possible next move instead of just blindly search for these 300 different positions. So the neural network can give you hints for like 20 possible best moves. This greatly reduces the search space. And also it plays with itself, and it trains a value network. A value network is like a human. We can evaluate in the current situation what's the probability I'm going to win. So combined with this, when it plays with Lisedo online, the policy network, as I mentioned, it will give you suggestions of possible moves. And the value network will calculate, assign each position some weights. And then basically, the innovation of DeepMind is that they use deep neural network to make the Monte Carlo tree search smartly. Smartly enough that it can be possible for a HP system with hundreds, thousands of CPUs to beat human. So I want to mention here, the technology here is not new. It is not brand new. It's known, like Monte Carlo tree search is known for decades, and deep neural network also being known for decades. But it's the engineering effort to put all the system together, CPUs, GPUs, also some tricks to make the numerical, optimization training stable. Courtesy to the engineering team of DeepMind. There's also other cool examples in image recognition. The top left one is an app that you can take a picture of your son's math homework, and it basically can recognize the equations and give you answers. So, and the whole, it just recognize the image and extract these characters and do some calculations. The bottom left one is for automatic driving car. Automatic driving car is very hard because right now we have the technology that can allow cars with cameras to detect the object, pedestrians, the blocks, and the cars in front and make smart move. On the bottom right is the picture of our heart, MRI picture of heart. So recently there's a competition that asks you to predict the change of your heart volume during a series of MRI images. And this can be an indicator of potential heartbreak. So convolutional neural network dealing with images work extremely well as long as you have data that are labeled, that are validated from a human expert or with ground truth. So another example is image caption generation. So right now we can classify image, but that's not enough. We need to understand what's inside. We need to describe, understand the image really. So here comes people train a convolutional neural network where you give the neural network a bunch of images and also a bunch of descriptions. So you ask the neural network to figure out what's the best way to describe an image. Of course, this takes a very long time to train, and in the end, it works reasonably well. Like a blondie, a woman dressed in white leans against a white car. Yeah, it's kind of very reasonable. So another field which is heavily researched today is neural machine translation. So the current Google translation system, they rely on engineering tricks. They are not fully automatic. One cool feature of deep learning is fully end-to-end. Means you do not need to, for example, in the left, you just feed it into English and then do the translation to French. In the previous applications, you need to use some statistical machine translation methods, so it's semi-automatic. And it's not there yet. The performance is not, it's reaching as competitive as the previous method, I think in recent years. Also, one cool application is neural arts. I don't know whether you heard about the auction of some neural arts images from Google, which is acquired by people with $8,000 US. Like basically, you compose a content image like the church from Dome or our building in front of us with some style image like the scale or some other style image. You want to compose them to make them look like some really arts. This is just what I did on this on our CSCS GPU clusters. It might not be that beautiful to you, but there's really some beautiful pictures online that you might check. Just search neural arts, or there's even codes online. If you have GPUs, you can install a Cafe or other deep learning libraries to play with yourself. It takes a little bit longer, like an hour to train, to generate a good, nice looking image. But with the advance of deep learning technologies, in the future, you can paint a very beautiful picture, any style you want, you know. So, yeah. So next, I'm going to talk about recent updates of deep learning. So there's few trends. One is the network is going deeper. So remember the ImageNet computation. Initially, 2012, they have like 10 or 20 layers or less. And now, 2015, the Google Inception model, which is called GoogleNet, it has more than 50 layers more, which is crazy. I don't know how they design it. It was said it's calculated, but the theory behind how to design neural network is very kind of active research, and there's no clean rule or formulas to design this way or that way. And the recent residual nets from Microsoft research features about 200 layers of neural networks. Remember, why we want to go deep? Because we want to extract more and more features, different features, then hopefully we can understand the global story of our world. So that's these crazy people tried 200 layers, and it's the most state-of-art result. Also, another trend is go multimodal. Multimodal means you do not only want to model an image, but you also want to model others, like languages or audios. You want to model them together like a human. We get input to images, or also my audio signals, which might be better for you to learn fast. So here, in this image, you not only recognize the objects in the picture, which is kind of easy, no? You want to really understand, like a person is playing guitar, or person is using microscopy examining the patient. You want to learn these relationships between words detected in the images. And this is the, I think it will be the active research in the next 5 years. Also, I mentioned we are going end-to-end. We want to fully automatic the cubism systems, like speech recognition. Before deep learning, we have to engineer lots of systems, combine them in a pipeline to make it work. With deep learning, this is shown by Baidu research. Their second version of deep speech recognizer, they can take inputs of speech and then train a big neural network on their optimized HPC system. So here I want to mention optimization on HPC system makes advances of deep learning very well. They can make it train the big neural network 7 times faster, which means they can optimize in a very efficient way. So another trend is go with attention. Our humans, which is a concept brought from our humans, when we look at something, we have attention. We focus on one point with our energy, and and all the other surroundings are got blurred. So in natural language study in particular, when you do translation, the system without attention works like this. You have a bunch of inputs, and you want to output a bunch of outputs, and then in the middle are the hidden layers. So you get thinking this way. You compress your knowledge of German into a vector. A vector then can be decoded in a way that can be decoded into English. So what you get the information from is the hidden layer, the last one. But with attention, with attention, you want the network to get basically have weights, combinations of different inputs hidden layer to, it's loosely coupled with the concept attention, but it works better, and it's the next big thing of deep learning. Also, there is a trend for specialized chips doing neuron computation, like Qualcomm, IBM, they released their prototype of some chips. I don't see any workable or like right now mature product, but it's kind of trend. Looking forward to that. And so where deep learning is going now, we solve the images recognition problem. So people in the computer vision community is moving to understand videos. So there's millions of videos on YouTube. So basically, when I want to learn like assemble a bad board from IKEA, I watch a YouTube video. So ideally, we want to train a neural network that can understand videos. There are different tasks, of course. We want to understand the actions, gestures, the scenes, the everything included in a video. So these are competitions. I have to mention deep learning is motivated by competition. So if it works, that's great. If it didn't work, then we won't believe your method is better. So this is a ActiveNet classification task where you have thousands of videos. You want people to compete on classifying 100 different classes. And this is very challenging because the data is about terabytes, and to train them takes a very, very long time. So we really need advances from the HPC community to make training feasible. Also, deep reinforcement learning also is very active, and natural language understanding. There's a recent, I don't know whether you heard about this Allen AI Science Challenge, where they ask you people from all the world to answer the questions of 8th grade students' scientific homeworks, like chemistry or biology, physics, with real reasoning behind them. So, and the best performer on this competition got below 60%, which means he fails the exam. So our deep learning system currently cannot really understand, cannot really do reason stuff. So it can work on AlphaGo, but for understanding natural language, it's very tricky, taking into account the huge amount of connection relation between words and grammars. So it's the next thing we want to crack in deep learning. Yeah, at the end, I want to mention unsupervised learning. So unsupervised learning is a real, the way we humans do. We learn something without, we learn something every time without being taught, and we have this real intelligence. So I want to quote from Yann LeCun, which is the pioneer in this field. He is very angry about the exaggeration of a misinterpretation of the victory of AlphaGo. So, it's not true that we saw the true AI. True AI means we can make a machine that smart enough to can reason. Basically, we can reason. AlphaGo make modes, but it's not with true reasoning behind it. So in summary, I want to use this person, Darlene Akaji's summary. deep learning excels at taking these raw basic units like raw pixels, audio signals, or words, where they are loosely have little meaning in itself, but the combination it makes very useful meaning. So deep learning is really good at that. And learning are toward an end-to-end fashion. So it's fully automatic, then you don't need to worry about that. Also, the current system are restricted with the data you prepared. You need to have structured data, well-defined cost function to train it. That's why deep learning is so popular in this image, speech field, but it didn't progress much in more complicated data like biologic data, genomic data. They are so they are just unstructured, and you don't know what the DNA sequences mean intuitively. So some thoughts about deep learning. I want to argue that deep learning will change our lives in a very positive way. But there is still a long way towards true AI. So don't worry, deep learning can be evil, it will kill humans. There's still a long way to go. So what might happen in the future is that like AlphaGo. AlphaGo can be our friend. It can teach you Go quickly. Like right now, the Go players, all the young Go players all learn by competing with the computer programs. So the computer program, if they are smarter, they can teach you quickly and you learn fast, and which is the positive side of these deep learning applications. So if you are fascinated by deep learning applications, you should go to this GitHub list of awesome deep learning. It has a whole collections of tutorials, videos, codes, and papers, so it can give you a thorough understanding of deep learning. And thanks for attention. I want to thank my colleague for useful comments on my slides, and thank you for your attention. Thanks. Any question? Hi. Yeah.
Okay, so how about unsupervised networks like cojones networks and such things are being investigated in depth, or?
Unsupervised network there's one unsupervised network called autoencoders. Basically, you can train images like cats or dogs. It can distinguish them. It can learn the features of a cat, like learn the feature of a dog, but I just don't know, the semantics. This is a cat. It can learn the features. So it can learn in a network that can encode into some information and decode into itself. So you compress the knowledge of a cat into a network and into a vase, and compress the knowledge of a dog into a vase. But Google trained a large system in a surprise way, but it works really not well, because probably you need to train very, very long time, or yeah. It's just undergoing research.
Okay, thanks.
Any more questions? So, what is the hello world that you think that's the best approach if you're new to the field? If I want to do something with deep neural networks, but I only use Python, for instance. Is there a library
Python is nice.
Cool, or is there?
There's several Python libraries for deep learning. So works on single GPU, and you can easily use it with 1 hour. You can search online. It's called Keras. With like 100 or 200 lines of code, you can train a handwritten digital recognizer or a face detector. there's functionality for you to visualize, there's blogs that talk about what's going on. So basically right now is the perfect time for you to learn. 2 years ago, when I heard about deep learning, there isn't much code release, there isn't much paper talk about this. It's hard. You need to buy a GPU, you need to implement your own libraries or something to make it work. But right now, like Google released TensorFlow, Yahoo released the Cafe, Spark. There's all other open source libraries you can try. Any language, Java, Lua, yeah, you name it. Julia, Python, yeah, C++.
Yeah, okay, cool, thanks.
Yeah. Just search online or go to this awesome deep learning list. Yeah.
I wanted to minimize a problem, functions in a large space of parameter with nonlinear effect. Deep learning could be a great help, but I don't think how to build the neural networks. You know, what is there a method or a tools to build a neural networks to when you have a problems?
To clarify, your task is to optimize what? Your task is?
If I have a problem,
yeah, I have a problem.
Sort of minimizations, is there a method to build a neural network?
Okay.
To do that, I have the feeling that you need to be an expert to know which layer to put on each steps. And so
you want to use train a neural network to minimize your function, your program. Is that correct, the question?
A neural networks
yeah.
to solve the problem you have. You see what I mean? To help user to use. No?
So, yeah, there are conventions on how to design network structures. You know, we understand like for the convolutions and pooling, how they should be arranged, and these fully connections. Yeah, there's some common sense about how do you should put them. But the details of which kind of network should work best is unclear.
I have a question for you, actually.
Okay, thanks.
That has to do with a technology like InfiniBand. How much that could give benefits in deep learning if we just put that, joining it with accelerators like not what we have seen this morning, the Titan, but like K80s, and doing some of the RDMA that had been presented by DK this morning. So make this all combination. How much you believe that could give us a benefits in the deep learning?
Currently, yeah, these deep learning libraries are not scaled very well, and partly because of their implementation issues. But if everything works, I think we can achieve, and with the faster inter-server connection, I think we can get about linear, close to linear speed up. There's a framework by Microsoft which is called CNTK. It's like Cafe. It's gets about 7 times speed up out of 8 GPUs. So yeah, we can achieve very good speed up, I think.
Then we will follow for 2017 of the HPC advisory, showing some of the experimental we'll be doing this year.
Yeah,
show how much we can scale.
Yeah, I would like to run experiments on this GPU class. Also, the r-CUDA. I was wondering if we can implement r-CUDA into these libraries and see how scalable the system is. Yeah.
Intel released the Xeon plus FPGA prospect that that we can get an Xeon that has an FPGA next to it, and that you can, program.
Honestly, I don't know much about FPG, but I heard it's you need to be expert to program it. It's not like CUDA where software engineers can easily to interact with the GPU. So I think FPG might need some time to allow people to use it freely.
Yeah, sure.
Yeah.
One more.
Okay.
I just want to add comments like whatever we have observed so far, all these deep learning frameworks are actually using very large messages, very large. Unlike a lot of HPC applications where short message, medium message performance matters, here very large messages, and this is where InfiniBand has the highest bandwidth.
So that we definitely will gain a lot.
Yes. So but as he indicated, yeah, the implementations need to be done properly. I mean, that's what we are exploring.
Yeah.
We'll see.
Yeah, thanks.
Thank you.
We're looking forward.
Yes.
Okay. So if there's no more question, let's thank our speaker.
Thank you.